is over. We're going to resume class. Before break time, we were talking about the TLB and cache operation. We have the virtual memory system that must interact with the main memory, cache memory, as well as the translation look aside buffer. So virtual addresses are typically structured as a page number and the offset. The memory system, we first check the TLB to see if the page table entry is present there. If it is present there, it is a TLB hit. Then the physical address needed to be generated by combining the frame number with the offset. If the TLB is not present in if the page table entry is not present in the TLB, so we have the page table entry that needed to be retrieved from the page table into the main memory if the page table is available there. So if the page table is not available into the main memory, that is a page fault. It is a page fault. We have the system that needed to expand the page table entry request to the next level into the main memory hierarchy, which is the next level is the external memory. It is the disk. So it is a page fault, and it's gonna take more time to get the page retrieved and the physical address as well. So any question related to memory management techniques, swapping, paging, virtual memory? Any question? Before we move to the next lecture, input-output devices and their interaction with the microprocessor. Any question? Question? You have exam this afternoon? No? Since you are quite busy. So, remember that this lecture is included in your final exam. Any question? All right, since there is no question, so this is the end of lecture number 18. Before we start the lecture number 19, there is a small task to do. We have a computer system with a virtual memory with 4 KB pages, and each process has a 20 virtual bit address space. We need first to determine the number of bits which are required for the page number. We also need to determine the number of bits which are required for the page offsets. So the next question is about to determine the total number of pages in the process is virtual address space, and you need to show all your calculation on how you have got the answer. So you have 5 minutes to complete this. Zaima, are you there? Huh? So you have 5 minutes to complete this exercise. is the finish? Done? gonna start the last lecture for this course. The topic is related to the interaction of microprocessor and input-output devices. As we have seen when we learned about memory system, we have the input-output that are very important in the computer system. So we needed to talk about the input-output and their interaction with the microprocessor. So the main topic that we're going to discuss for this lecture and the next one is going to be input-output device. We're going to talk about the interaction with the microprocessor. We're going to talk about the memory mapped input-output. We're going to have to talk about the interrupt driven input-output and the DMA, direct memory access. But before we start talking about more about input-output devices, here are some common input-output devices. We have the keyboard. When you want to interact with the computer system, you may need to type something from your keyboard. You need your mouse, you need the scanner, you need a microphone, for example. If you are teaching or you are talking to a very big audience, you need a webcam. When you are on video calls, we have a joystick, we have a barcode reader as well. So these are some common input devices. For the output devices, we need a monitor, we need a projector, we need a printer, we need the speakers, and so on and so forth. So these are some common input and output devices in our computer system. Now, here we have a picture which depicts the generic model of the input-output module. We have the input-output operation that needed to use external devices to exchange data with the computer. Then devices are connected via input-output module. So we have this input-output module to connect all the devices. So the link needed to carry the control, status, and the data signals. We have external devices, such external devices which is there to connect these input-output devices is called input-output module, and such external devices are called peripheral devices, or they are shortly called peripherals. Now, from this picture on the screen, we have a bus system which include the address line. The address line are there to transit addresses, and we have the data lines which are there to transit data. Then we have the control lines which are there to transit control, status, commands. So here, this is the generic model of the input-output module, which is there to connect all the input-output devices. And we have input-output operation that needed to use external devices to exchange data with the computer. All those devices needed to connect via a link to an input-output module. And the link has to carry the control, status, and data signals. Next, we have different categories, 3 different categories of external devices. We have human-readable external devices, which are suitable for communicating with the computer system. Now, we have input devices. We also have output devices as examples of human-readable external devices. Another category, the second category of external devices are what we call machine-readable external devices. Those devices are suitable for communicating with the equipment. We have, for example, the storage devices, which include the HDDs, hard disk drivers or solid-state drivers, SSDs. Now, we can also have another example for machine readable. We have sensors, barcode reader, RFID scanners, temperature sensors, and so on and so forth. All these examples belong to the category of machine readable external devices. The third category of external devices is communication, which are suitable for communicating with remote devices. These include, for example, modems that we use for internet or telephone line communication. We also have to talk about the network interface card, NIC. We also have to talk about routers and switch, Bluetooth, or Wi-Fi adapters. All these communication external devices are very important, and they are suitable for communicating with remote devices. You may have learned these external devices which are suitable for communication in your computer networks course. Here we have a block diagram of external device, which include the controller logic, the buffer, as well as what we call transducer. We have here input-output module interface, which use the control, data, and status signals. We have control signals which need to specify operations like read, input, write, output, or status report like device-specific action for the disk head positioning. So we have a data signal that needed to carry bit to or from the input-output. Then we have status signal that indicate the device is state. Example, we can have a status of ready. When the device is ready to receive or to send the data, we can have not ready, as well as an example of data signals, status signals to indicate the status of the device. Now, we have here control signals from the input-output that need to be sent to the controller logic. And the controller logic will respond with the status signal to the input-output. Then we have the data that need to be sent to or from the input-output module. Now, we have a kind of buffer, a buffer here which temporarily transmits the data, and this typically has a size of 8 or 16-bit for serial devices. We may also need a big buffer, especially for block-oriented devices, like the disk controller. So this is a block diagram for external device, which include the control logic which will receive the control signal from the input-output module. Then the control logic will respond with the status signal to the input-output. Then whenever the control logic confirm its readiness, there will be data bit which will be exchanged to or from the input-output module. Now, we have a buffer which is there to temporarily store the transmitted information. We have different size of the buffer depending on what type of devices which is in communication with the computer system. We may have 8 or 16-bit buffer for the serial devices, or we may have a bigger buffer for block-oriented devices like the disk controller. Then we have the data to or from the environment. Transducer convert the data between electrical and other type of energy forms from the input-output devices. So this is mainly the block diagram of the external device, which include the control logic, which will receive the control signal from the input-output module, and the control logic will reply with the stellar signal to the input-output module, and we have the data that needed to be transmitted to or from the input-output module. And this block diagram of external device include a transducer to convert data between electrical and other type of energy forms for the input-output device. And we have also a buffer to temporarily store transmitted data. And this buffer has different sizes depending on what type of devices. We may have 8 or 16 buffer size for serial devices, or a bigger buffer for block-oriented devices, like the disk controller. Now, what are the main functions of the input-output modules? We have the control and the timing as the first function of the input-output module. The second function is the processor communication. The third one is the device communication. The fourth one is the buffer, data buffering. The last one that we're going to discuss in today's class is the error detection function of the input-output module. Now, let's get started with the first one, control and the timing. Now, we know that the processor needed to interact with multiple external devices based on the input-output needs. So this is very important to have this control and the timing function of the input-output module, which allows to get access to the different internal resources, including the memory, main memory bus system, which are all shared among several activities, including the input-output devices. So these input-output devices require this function of control and the timing to control or to coordinate the data flow. We have these input-output devices which require the control and the timing to coordinate the data flow between internal resources as well as external devices, So this control and the timing function of the input-output module is very important because it does allow the input-output devices to coordinate the data flow between internal resources and external devices. Here we have a simple example about data transfer between a processor and external device. We have the first step is the processor which communicates with the input-output device via input-output module. We have here we have this example, the sequence of data transfer between the processor and external device. We have the processor on one hand. We have input-output module because all the communication between the processor and the input-output device is done via the input-output module. So step number one, we have the processor which sends what we call a check, status check of the device. We have status checks, send it to the external devices via the input-output module. Then we have the input-output module that needed to return the device we send the status to the microprocessor via the input-output module. We have the device which reply about status to the processor. That is during the step number 2. We have step number 3. We have the processor that requests data. If the processor has got the ready status from the device, let's say the device said ready. We have the processor which requests data transfer request. Transfer request. To the input-output device via the input-output module. We have data transfer request. Then step number 4, the input-output device will retrieve the data unit from the device. Then we have the data that needed to be sent to the processor. That is step number 4. Step number 4, we have the device here, which needed to return the data to the processor via input-output module, data unit transfer, data unit 16 or 8-bit, depending on what kind of device it is. Then the data will be transferred from the device via the input-output module to the processor. Data is transferred from the input-output device to the processor, and if a system bus is used, each instruction involves what we call bus arbitration. So you need to understand that during this communication of the input-output device, this device needs to communicate with the processor via the input-output device. Input-output module is very important to coordinate the communication of each input-output device with the processor. Now, if a system bus is used, that means each interaction involves a bus arbitration to indicate which device is the bus master or slave. All right, so the next role, function of the input-output module is the processor communication. It involves the following. Command decoding. We have input-output module which receives command from the processor via the controller bus. We have, for example, ready sector or write sector. We have 6-track, scan, record, ID, and so on and so forth. And some code command include parameters that are sent on the data bus. The next one is the data transfer. Data transfer is exchanged between the input-output module and the processor over the data bus. Hello? Remember, we have the bus system. The bus system, which includes data bus, data bus, data bus to transmit data. We have address bus, transit address, and we have the control bus, transit controls or signals. And when the bus system is used, we have what we call the bus arbitration. This is the bus system. So we have status reporting, where the input-output module needed to report device readiness or errors using the status signals, busy or ready. So when it comes to the address recognition, we have each input-output device that has a unique address, and the input-output module has to identify devices based on the addresses. As we have seen for the memory communication, each memory location has a unique address, and if a data needed to be retrieved from a memory location, the computer system needed to use what we call memory addresses. Now, the next function of the input-output module is the device communication, which involves the command, status information, and the data transmission. Now, we have the control signals from the input-output that needed to be sent to the controller logic, and the controller logic will reply with the status signal to the input-output module. Then data bit will be sent to or from the input-output module. Then we have the buffer, which temporarily stores the data information, and the transducer, which is there to convert electrical signal and other form of energy for the input-outputs. So we have data that needs to be sent to or from the environment. So this is the device communication diagram, which includes the control signal from the input-output module, and we have the controller logic, which needed to send back the status signal to the input-output module to indicate its readiness about its communication. So here you can see that we have the control signal. We have seen this example of the communication of the processor and the input-output module. The first step is for the processor to check the status of the input-output device via the input-output module. Then the device will have to reply about its status of readiness or not ready via the input-output module. This is the second step. Then for the third step, we have the microprocessor that will require the device to send the data transfer request to the device. Then the device will have to reply with a data unit that needed to be sent from the device to the processor via the input-output module. And the data unit needs to be 8 or 16-bit, depending on which kind of device, which is in communication with the processor. Now, we have seen that if the system bus is involved, we need what we call bus arbitration to indicate which device is a master or a slave. Master, which is transmitting the data via the bus, and the slave, which is receiving the data. So this is very important. This device communication involves commands and status information, as well as data that needed to be transmitted from the device via the input-output module to the processor. Then we have this transducer, which is there to convert electrical signal to other form of energy in the input-output devices. Now, we have seen the data buffering, the buffer. Here in this picture, you see that we have a buffer. Now, what is the purpose of this buffer into the input-output module? What is the purpose? What is the purpose of having a buffer in the input-output module? Hello? What is a buffer? Why do we need a buffer in the input-output module? Huh? Why? Here we have to discuss about the data buffering, because we have the devices, external devices, which are very smaller and they are very slower than the input-output. The input-output devices are very slower than the processor, or they are very slower than the memory system. We need the data to be sent in what we call rapid burst to the input-output module. Then they needed to be stored in what we call buffer, and they needed to be sent to the device later on to avoid the waiting time of the central processing unit or the memory. Because if you compare the input-output device is speed and the processor is speed, we have seen that the processor is the fastest component into the computer system. So we needed this buffer to allow data to be sent in rapid burst to the input-output module. Then it has to be stored there before it is sent to the input-output device at a device speed. Because the input-output device have a slower speed if you compare to the speed of the memory system or the processor. That's why we need a buffer into input-output module to allow data to be sent into a rapid burst, into a rapid data unit. Then once it is sent to the input-output module, the input-output module include a buffer to store the data temporarily in data unit of 8 or 16 bits, depending on which kind of the communication it is. Then the data will be sent to the input-output module at the input device's speed. Now, the input-output module has to handle both memory and device speed, because we have seen that the processor and the memory system, they are much faster than the input-output devices. That's why the input-output module needed this buffer module to allow the data to be sent to the input-output module and stored into the buffer and needed to be sent to the device, to the input-output device at the device speed. If the device is faster than the memory, we have the input-output module that needed to store the data to match the memory access rate. Now, we have this data buffering image to depict why the buffer is very important. The need for the data buffering, the need for this function in the input-output module, it is very clear from this picture. Because while the transfer rate in and out of the main memory and the processor is quite high, we can see easily that it is not the same for the input-output devices. You see, here we have the Ethernet module. This is its maximum speed. We have the graphics display. This is its maximum speed. We have the hard disk. This is its maximum speed. We have the optical disk. This is its maximum speed. We have the laser printer. This is its maximum speed, and the scanner, and so on and so forth. So while the data transfer rate in and out of the main memory and the processor is very high, that is not the case for the input-output device. That's why we need the data buffer, the input-output module, to allow data to be stored in the buffer before it is sent to the last destination, which is the input-output device. Questions? Questions about the 5 functions of the input-output module? We talked about data buffering. We talked about device communication. We talked about processor communication. We talked about the control and the timing. So we're going to have a talk on the error detection and the correction in the next lecture. But just a short introduction. Error detection and the correction is very important in the input-output module. It is responsible to detect errors. It is responsible to collect errors when possible. Now, when we talked about the communication with the processor and the main memory system, we have seen that errors can happen at any time. So we need the system to detect and correct errors. And we have discussed different memory error detection correction techniques, including the parity check as well as the Hamming code. So we're going to also have a short look on the error detection correction for the input-output module, because with the communication with microprocessor and the input-output devices, errors also may happen. So it's better the system, the input-output module, have the capability of detecting and correcting the errors when is needed. Questions? So if there is no question, this is almost the end of today's class. We're going to continue with this lecture next time. So until next time, take care. A short information, there is a makeup quiz for those who missed the quizzes. There will be a makeup quiz next Wednesday afternoon, and it will cover everything that we have learned in this course, and it is a closed notebook and it is closed book. You only need to bring a calculator, no mobile phone. Okay, clear? That's it for today's class. I will see you next time.